We are live.
Okay, okay.
So first of all, we'll start either you or me.
Yeah, you should start first, then I will explain my own later on.
Okay, no shoes. Is my screen visible?
Yeah, your screen. Yeah, it's visible.
Okay. So guys, today our question is to count nice pairs in an array. So what are nice pairs? For example, let me show you an example. Mm, So for example, we have been given an array 42. So we have been given an array 42, 11, 1 and 97. So we have to count the number of nice pairs that are available in this array. Nice pairs are defined as if the if the number at ith position plus reverse of number at jth position is equal to number at jth position plus reverse of that number at ith position, which can also be calculated as that num psi minus reverse of num psi is equal to num psi j minus reverse j. So for example, in this array we can see 42 plus reverse of 42, what it is, 42 plus 24 is 66, and mhm, and 97 plus reverse of 97. Okay. Oh sorry, it's minus of.
Yeah, yeah, that is what I was mesmerizing about that.
Yeah,
Yeah.
that's why it's giving different value.
Mhm.
So 42 minus 24 is 18, and we take at index 3, which is 97. 97 minus 7, it's also 18. So we got one nice pair. So and we take about index 1 and index 2, 11 and 1, it is 11 minus 11, which is 0, and 1 minus 1, which is also 0. So we got two nice pairs in this array. So how can we approach this problem is, first of all we can calculate num psi minus reverse of num psi of all the positions in that given array and
Mhm.
store it in a hash map, and then we can check if then we can traverse the array and find if it is available or not. If it's available, then we can like store its count in a variable. So let me write a code. First of all, we can write a code of reversing a number. Okay, so we go so we have a reverse a number function. First of all, we need to check if that num psi minus reverse of num psi is available in that in the our map. that's available, we need to increment it. And after that we need to increment its value. Yeah, we can return our answer. Okay, and we need to submit it. Okay, so here we haven't got an error because in the question it's given that if the values are too large we need to return it in a modulo. So we can simply return its modulo. Okay. There's some type issue here. Oh yeah, it's 7 or 9. Yeah, it got submitted.
Okay.
Okay, now to you, Sangam.
Just give me 5 seconds.
Yeah, no issues.
Yeah. So is my screen is visible?
Yeah, it's visible.
See guys, so the question that we have been asked today is to determine if two trees in a given binary tree are equal or not. So as you can see that here we have been given two trees, both have similar value 1 2 and 3 and 1 2 and 3, and if they are similar we just have to return true yes, and if they are not, that in example 2 we can see that it is 1 2 3 and this tree is 1 3 and 2, so they are not equal, so as a result we are going to return false. So now let's just first of all understand that how we are actually going to solve this problem. Firstly, this problem is just basically a thing that in a given binary tree at any particular node there are four things that we have to consider. Basically two things, but if we are going to make part of it, then yeah, there are four things. First thing is that either the given node is null. The second thing would be that either the values of these given binary tree are equal or not. If they are, then yeah, we are going to return true. If not, then we simply need to return false. The third thing that have to consider that either one value is null and the other is not. Then that tree is not going to be a symmetrical binary tree. The reason behind that, let's just say we have two trees, 1, 2, and 3, and the other tree is 1 and 2. So if we are comparing for the node 3, for tree 1, yes, the node 3 is available, but the 432 for node or tree 2, the node 3 is not available. So that is what we have to check in this third thing. And the fourth thing that we have to consider is that either the values are equal or not. So thing that we are going to do is at any particular given node, the first thing that we are going to find out or check that either this node is null or not. After we have checked that okay, this node is not null, the second thing that we have to check that if their value is equal or not, because if this node has different value and this node has different value, then there is no point of going downward that binary tree, because then we can just return the value from this point. Why would we even travel down the road when we just able to find out that the tree is not symmetrical? So when we figure out that yes, the value of the given node is not equal to the value of the corresponding tree, we are simply going to return false. That is the second thing that we have to check. The third thing that we have to check that either one node is null and the second one has value. So as a result, as we have already discussed in case of node 3. And the fourth thing is that either values are different. Let's say this is a binary tree and this node has value 4. Now node 3 and node 4, they are not null, but their values are not equal. So as a result, we are just simply going to return that the tree is not binary tree, equal binary tree. Now how we are actually going to proceed with solving this problem? So let me just give you a dry run so that it will make it more easy for you guys to understand that how we are actually moving down over this function that we have already written in case of this tree. So first of all, we are at node 1. Okay, for both tree we have a tree with pointer r1 and another tree with pointer r2. Now the first thing that we are going to check that if R1 is equals to null, that if one is null and the other is not. So in this case, as we can see that one is not null and this pointer that is pointing right now, that is R2 pointer, is also not null. So we are well past this condition. Then the second thing that we have to consider that either both are null. So as we can see that both have a distinct value. So this condition is also not satisfied. Then the third thing that we are going to do is that either the value of this tree is equal. So if we see the value of one node is equal and the value of two node, if we compare it collectively, we are going to find out these values are equal. If we find this condition to be true, then and only then we are going to check for the left node and for the right node of this binary tree. So what we are going to do after we check this condition that yes, this condition is not satisfying, this condition is not satisfying, but this one is satisfying, only then we are going to go and proceed for the left and right. Now when we reach for the left of this binary tree, again we are going to do the similar thing. So first of all, we are going to check that either any of these values is null. As we can see that 2 is not null and the pointer that is pointing right now to R2 is also not null. So these both conditions are not satisfying. Then we are going to move that either the value of this node, that is the value which R1 pointer hold, either it is equals to the value which R2 pointer hold, as in this case 2 is equals to 2, so we are here good to go. Then the next thing that we are going to do, as I already discussed you, that if the values of those symmetrical tree are equal, then and only then we are going to proceed to move towards its child. So in this case, as we can see that both the left and the right child of node 2 of both tree is null. Now we are stuck with the condition this. So after that, after we have done this, now we are at this node. Now for both tree we are at this node and these node are null. So here first of all the condition will be checked that either one is null and the second is not, but in this case as we can see that both are null, so this condition is not satisfying. Then we are going to check that either one is null and second is also null. So as we can see that both these nodes are null, so here we are going to return true. And if we find any node in the tree that satisfy this condition, we are simply going to return false. And any node in the tree that satisfied R1 value is not equal to R2, we are simply going to return false. For these two value, we are going to return true. So if we see from a perspective of this binary tree 1 2, and let's just say its value is 4. There is another binary tree, let's just say its value is 3. So for this given binary tree, what is going to happen is that first of all we are going to check for node 1, and we are going to see that yes, these values are not null, and along with that they have equal value. So as a result we are now going to move toward its left child. So as we go toward the left child, we are going to find out that for both these three, left child are not null. That is the first condition, and the second condition is that these both have similar value. So as a result we are going to go down. Now after we go down for this value, we are going to find out that yes, both these nodes are null, and if that is the case, we are going to return true. Now after we have returned this value to true, so this value also have nothing and nothing where to go. It will also go back and will return true. Now after it had returned true, the one node will go towards its right pointer to check to right node to check whether the value is equal or not. So after we reach the node 4 and the other tree the node 3, we are first of all going to check that either any of the node value is null. So we're going to find out that both these node has some value, so they are not null. So first condition is not satisfying. Then we are going to move toward the third condition, that either the value of these are equal. So as you can see that 4 is not equal to 3. So and we have already learned, guys, we have already learned that if values are not equal, we are simply going to return false. So as a result, here for this value, we are simply going to return false. There is no need to move forward, no need to do anything, just return false. And as we can see that one node is returning false, thus these two trees are not symmetrical. And if we get the truth value, if we get correct value for both of these nodes, then yes, the tree is going to be symmetrical, as we can see in this case. It will move down, it will move down, it will move down, it will move down. Null condition will be satisfied, will return true, will return true, and this will also value will have true. Same for this one, will return true, will return true, and will return true. So just keep in mind, there are just four conditions that we are keeping in mind. The first thing is that either both pointer are null, or either only one pointer is null. If one pointer is null and other is not, we are going to return false. If both are null, then we are going to return true. Then the second thing that we are checking is that either both node value are equal or not. If they are equal, then we are going to move toward the further ends of this binary tree to check all the other elements. If they are not, there is no need to go down any path. We're just simply going to return back and return false as an answer. So as guys, I already stated you that what is the logic. Now let's just come back and type the code and see how it is working. So first of all, what I have done is that there is a function they have given us, and in that function they have given us two pointer. These are pointing towards a node of the given binary tree, and in that case it would be r1 and r2. They are pointing toward the 1 and 1 of 1 and 1 node of this binary tree. Now after this I am going to call this function dfs of r1 and r2. Now in this function is going to return bool, because that is what we want. We want either answer in the form of yes or in no. There is no need to do anything else. Then the next thing that we are checking, as I already told you, that either r1 is null or r2 is null. So either both the pointer are null. If that is the case, then simply return true. And if that is not the case, that either one is null, that is r1 is null, or r2 is null and r1 is not, then we are simply going to return false. Now after we went through this course, if this condition, the first condition, is not satisfied, let's just say not satisfied, and the second condition is also not satisfied, the function doesn't go anywhere, it will not satisfy, then and only then we are going to move toward the third condition, and which states that if r1 ka data is not equals to r2 ka data, that is the value of if, as we have already seen in this tree, that if the value of this node is not equal to the value of this node, just simply return false. And that is what we have done in this case, that if that is the case, just simply return false. And if this condition is also not satisfied, satisfied, then the next thing that we are going to do, move down to what? Move down to further traversal of this tree, and that is what we have done. We have actually given them that r1 data is equals to r2 data, that yes, this value is true. What we have given is that true, and along with that I am now just going to check for left and then for right. That is what I'm doing. This value, for this node value, it is true, and then I'm going to check for left and right. And let's just say I, as I go down the road, and I found out that for left it is not true, like for left it is false, and for right it is true. Now when the moment I got false, this whole return statement is going to return false, and as a result we are going to give the output that the answer is false, that the trees are not symmetrical. So that is what we have done. As I already told you, there are four conditions that we are checking. First of all, that either the values are, one value is null and other is not. The second condition is both are null. The third condition is either the values of both nodes are equal, either not. If there is any condition that one is different from the other, or one is null and other is not, we are simply going to return false. And if there is other two cases, then we are simply going to return true. And that is what we have done in this case. First condition, second condition, third condition, and then the fourth condition. Here we are just traversing down this binary tree. And if we just simply going to submit this code, it will work perfectly fine. It was actually quite a simple question, but takes some time, but quite simple. So I hope you guys that I am Shivam. I and Shivam are able to make it clear for you guys that how you can solve this POTD of today. Until then, we will see you tomorrow.
So yeah guys, thanks for joining with us. Okay, bye bye.
Okay, guys.